All right, so our last section we're going to look at today is 10.2. And the big difference is we're going to be focusing just on 3 variable equations today. So I don't think we're going to do that many 2 variables. It's going to be 3. And the method we're going to learn today is basically a very systematic way of doing it. If you don't mind the method that we did yesterday, 2 days ago, you can use that method. It's just sometimes that method is going to lead to having more choices. Like which equations do you want to use, which letter do you want to eliminate. This method takes out all the choices. So you follow the exact same method every time. So it's just a different way of doing it. It's the kind of method that if you were going to program a computer to be able to solve it for you, you would use this because it's a very exact thing you do every time. There's no random choices you have to make based on what you think you should do. All right, so let's see. We're not going to review this. This was a review question that I was going to do, similar to what we did yesterday. If we were going to do it, which variable would be easy to eliminate? You could do x. I would say that's a good one because I see some x's with 1s. Or you could do z. So already you have a choice, x or z. And then once you decide which variable, maybe you eliminate x from equations 1 and 2, and then you do it again with 1 and 3, right? Or if you do z, you're going to probably do it with 1 and 2, and also with 1 and 3. Okay? Or you could eliminate z. No, that's how I would do it. Yeah, but you still have choices. Okay? We are going to do this problem, but we're going to do it a little bit differently. Okay, we're going to do it as a matrix. So that's what we're going to transition to using now. So a couple things that are different when we solve it as a matrix. One, it's a lot less writing. Okay? We don't have to write down any letters. As we're solving the problem, all we do is write down numbers each time. So it is less in terms of that. And it's an exact method that we follow every time. Okay? Listen. Okay, so first thing is what is a matrix? Okay, you can kind of think of a matrix, it's like a table. It has rows and it has columns. And the way that we describe a matrix is usually by its dimensions. You say how many rows and how many columns. So if you had a 2 by 3 matrix, that would be something like this. And you'd have numbers in each one of those 6 spots. That would be 2 rows, 3 columns. So that's 2 by 3. If the number of rows and columns is exactly the same, then we call that a square matrix. So for example, like a 2 by 2. If you had numbers in those 4 spots, that would be a square matrix. We're going to be working with a square matrix that looks more like this. What would be the dimensions of this one?
3 by 3.
Yeah, it'd be a 3 by 3. There'd be a number in each one of those spots. They can be fractions, decimals, integers. We try not to use fractions and decimals because that's going to make the math harder. Right? But if we have to, we can. So each number in a matrix is called an element. And the way that I would ask you, let's say we had these, let's make up some numbers, 6, 8, 2, -1, -7, -5, -3. Okay, they're all different, right? Yeah. So if I said to you to identify the number that's in row 3, column 2, right, it would be -5. That's the 3rd row and in the 2nd column. And the way that we write that is using this kind of notation. So we put a letter, and then as kind of a subscript, the row and the column that you're looking for. So if you were looking for the number in row 2, column 3, that's how you would write it. Row 2, column 3. That's that number right there. A matrix is generally named with a capital letter. That's not really going to be important for what we do because we're not going to be naming the matrix, but Generally, if you have a matrix of numbers, you just name it with a single capital letter. And in our book, when they refer to something within that matrix, they use the same letter as the name, but they make it lowercase. So a lowercase letter in our book refers to something within the matrix. The capital letter itself stands for the entire thing. Any questions on that? Just a few kind of background things about what a matrix is. Now, there's a lot of things you can do with matrices. One of them is solving systems of equations. Okay, that's the one we're going to do. But there's like an entire class you can take just on using matrices to do things in math. Some things you already might know how to do, and some things you've never done. The one we're going to do is something you already know how to do, solve a system. So it's going to be kind of an alternate way to do it. I think I already said that to you. So the advantage of a matrix, it's really two things. One, it's a very organized way to solve it, and it's exactly the same way every time. And you don't have to write down any letters. Okay, what we do have to write down is the numbers in front of the letters. Okay, we have to keep track of all the coefficients. So if we're just writing numbers, then how do we know, if we did something like, let's say 2, 1, 5, -8. How do we know where those numbers were? Like when we turn it into a matrix, all the letters are gone. Well, each column is going to represent a variable. So let's say we had something like this, 5, and let's do a different number. I just want all the numbers to be different so there's no confusion. If you wrote that down, okay, what's on the board? That top row would mean this. 2x plus 1y equals 7. That matrix is a shorter way of writing down that equation. Okay, the bottom row would be 5x -8y equals 6. So generally, when you write a matrix, the first column is always going to represent the x's. The second column would be the y's. And that third column would be the number that goes on the other side. That's how it would work if you have 2 rows and 2 columns here. Now, if you extend this side to have 3 rows and 3 columns, well, then the first column would still be the x's. The second column would still be the y's. But what do you think the third column would be? It would be the z's, and then you'd have another column, and that would represent what goes on the other side of the equation. Okay, so just think of a matrix as a short way of writing down an equation without the equal sign and without any of the letters in the problem. Now, all of these numbers, right? 2, 1, 5, -8. They're the numbers in front of the variable. What do you call those numbers? They're all called coefficients. So when you take all of these coefficients and you write them down, what I just put a box around, that's called a coefficient matrix, because it's a table, right? It has rows and columns. That makes it a matrix. And the numbers in the table are all the coefficients of your variables. Okay, so that's called the coefficient matrix. Now, if all you do is write down the coefficient matrix, say you don't put anything else. So let me get rid of everything over here. The problem is you haven't written down the 7 and the 6. You've written down the 2, the 1, the 5, and the -8. You need to also have the numbers that are on the other side, because that's part of the problem. Those are important to keep track of. So what we do is generally we put kind of like a dotted line, or sometimes you even see a solid line there. And that solid line is just there to separate and say, okay, everything on the right of that dotted line are the numbers that were on the right of the equal sign. So we add on, or we augment, we add on to that coefficient matrix one more column, and that column represents the numbers that were on the other side. Okay, so using a matrix to write stuff down, that's pretty straightforward. Let's just try writing something as a matrix, make sure we can do it. Let's say I had 3x plus 2y equals 5, and negative 8x plus 4y equals 6. Okay. If I was going to write that as a matrix, what would be my top row? What numbers? Yep.
3, 2, 5.
Right, we're going to do it just like that. We put 3, 2, put a line, and 5 on the other side. How about my bottom row?
Negative 8, 4,
Yep.
6.
Negative 8, 4, and 6. Perfect. Okay. Let's try one more. I know that's only 2 variables. We are going to do 3. But it's the same idea. Let's try this one. 4x minus 8y equals 12. And 3y plus 5x equals 7. Okay. What would my top row be there?
4, negative 8, 12.
Okay, so that's fine. 4, negative 8, 12. What would my bottom row be?
3, 5,
7,
7.
5, 5, 3.
It would not be 3, 5, 7.
5, 3, 7.
5, 3, 7. Okay. Why?
Because of the x's and y's.
Yeah, this isn't set up right. Okay. X's have to be in a column, Y's have to be in a column, and then the number on the other side without the letter has to be in a column. All right. So we got to make sure when we write this one down, we think of it as 5, 3, 7. Okay, so that's important. Okay, so the goal is basically to take our coefficient matrix, which is this part that has a box around it, and turn that into having lots of ones and zeros. Okay, ones and zeros are going to make life a lot easier because it makes arithmetic easier. So let me show you an example of something we're going to try to get. All right. So let's say we had something like this. And then what's here doesn't matter. And what's here and what's here doesn't matter. But that's the goal right there. To somehow try and get ones on what we call the main diagonal. That main diagonal goes from the upper left to the lower right. And everywhere below that, we want zeros. What we have above it, it doesn't matter. It could be positives, negatives, decimals. We don't even pay attention to the numbers that are in the upper right part. It's the numbers that are on the diagonal and the lower left part. So we try to get ones on that diagonal, and we're going to try to get zeros underneath it. That's the goal. And there is a certain order we do it in, and I'll remind you of the order kind of as we go. But you do this one first, that one second, and that one third. You have to do it in that order. You do that one fourth, that one fifth, and that's the last one. If you don't go in that order, this method won't work. Okay. So we go 1, 2, 3, 4, 5, and that's always the last one. 6. So any question on the, like, what would physically, like, what it's going to look like? That's what it's going to look like. We're trying to get something that looks like that. That's the same picture. It's just representing ones on the main diagonal and then zeros everywhere underneath it. Okay. The one I did the circles in blue, it just lays it out a little bit better than that picture. That type of arrangement of numbers, okay, that's called REF, okay, or row echelon form. That's the name of something that looks like that. Ones on the main diagonal and zeros below it. Probably not going to use that term a lot, but that's what that means. It just simply means one on the main diagonals and 0 below it. Okay, so now, the last thing I need to show you is how can you do that? Okay, what are you allowed to do? Because you can't just take a matrix and just do anything you want to it. You can only do things to it that won't mess up the original problem. Okay? And that there's 3 things you're allowed to do to try to get zeros and ones in it. If you do anything other than the 3 things I'm about to show you, you will mess up the original problem, which means you will not get the right answer. Okay, so these 3 things I'm going to show you will not mess up the original problem, as long as you do it correctly. If you do what I'm going to show you wrong, well, then, yeah, it'll mess it up. So there's 3 things that you're allowed to do to try to get your matrix with 1s on the diagonal and 0s below it. And they're basically what we call operations. Right? Like in math, adding, subtracting, multiplying are operations. Well, I'm going to show you 3 things you can do in this matrix. You are allowed to take any 2 rows and swap them. That will not affect the answer to the problem. You could just think of that as having a different order I gave you the equations. That's fine. Right? So you can take any 2 rows and you can swap them. You can take a row and you can multiply it by a number. Right? And we did that when we did elimination. Right? So if you had something like this, and you wanted to eliminate one of the variables, well, I would say x's would be probably the one you want to try to eliminate, and I would multiply the top equation by what number?
-2.
Yeah, and that's exactly what this step means. You can multiply a row of numbers by any number you want except 0, because if you multiply by 0, then it wipes the whole thing out and then it's gone. Okay, so that step is really one we've seen before. And then the next step, if you multiplied everything by -2 here, then you would add your columns together. So you are allowed to add one row to another row. And this is another step that we do when we're doing elimination. So what we're doing today is elimination. Okay, it's a very systematic type of elimination, and it's called Gaussian elimination. So if you see questions in the homework that say solve the problem using Gaussian elimination, it means to do what we're doing today. All right, so now we'll just look at some examples. Okay, so let's take a look at solving this problem using a matrix. Okay, so remember the goal, what we're trying to get is row echelon form. That means when we're done, on the left part of the matrix, we're going to have a line here. We'll have 3 numbers on the other side, whatever those are. But we're going to want a 1, a 0, 0, 1, a 0, and a 1. Any of those spots that have kind of a wavy symbol in them, I don't care what's there. I don't care about any of those. So the first thing that we want is a 1 in the upper left. So I told you the order, I'll put down the order. You do this one first, this one second, that one third, fourth, fifth, and we do that one last. Okay, so the number in red represents kind of the number we're going to focus on. Is there a way that I could get a 1 in the upper left using one of those 3 steps?
Multiply the row by 1.
Well, if you multiply that top row by 1, it would just stay the same.
You just swap with the second one?
Swap.
Yeah, I would just swap it with the second one. So I'm not even going to write that as a step. I'm just going to do that as I write the original problem. Okay. So the first thing I'm going to do is write this down as a matrix. So I'm going to take row 2, and I'm going to put it in the top. So I'm going to have 1, -2, -3, and 0. It's going to be my top row. What's going to be my second row? 0, 2, 1, -8. Second row. And what about my third row?
-1, 2, 3.
3. Okay, so all we've done at this point is swap the first and the second row, and we've represented everything in a matrix. Okay, we don't have any more letters, and we're not going to have any letters until we write our final answers now. Okay. Any questions on that? So by swapping those two rows, we got lucky in this one, and actually two things happened. We got a 1 in the upper left, and we already got a 0 in the second spot, which is what we want. Okay. Any question on why we got a 0 there? Just happened because there was already a 0 for us. That won't always happen. All right. So now we're going to focus on spot 3. We need to look at row 1 and see what we could do to that row, and then combine it with that row, so this turns into a 0. Does anybody see what we could do with the first row and the third row?
Add it.
Yeah, all we have to do is add them. We don't even need to multiply by a number. If you just add row 1 and row 3, it will automatically make that a 0. Okay? So what I want to do is write down what we're going to do. So we're going to take, I usually put like an arrow like this to indicate that's my next step. And when I write a number and I circle it, that represents a row. So we're going to take row 1, and we're going to add it to row 3. Now, if that's all we do, that wouldn't actually change anything, because we now have to replace a row. When we add row 1 and row 3 together, that's going to replace what's currently in what row?
Row 3.
Row 3, exactly. So that means we're going to add row 1 to row 3, and the answer that we get is going to be in row 3. All right. So which rows are not changing in this step?
2.
2's not changing, and 1's not changing. So we can copy those down. I try to just change one row at a time, because if you do 2 rows at a time, then it gets confusing. So let's copy row 1, copy row 2, and now we have to do what we said. We're going to add row 1 and row 3 together, and that's going to replace what's in row 3. Okay. So what's 1 plus -1? 0. What's 2? -2 plus 1?
-1.
So -1. What's -3 plus 2?
-1.
It's -1. And don't forget the other side. What's 0 plus 3? 3. So once you get that first column with a 1 in the top and a 0 and a 0, you've now turned your problem into this. There's an x and a y, and another x and another y. So effectively, we just eliminated the x's from equation 2 and equation 3. That's what we just did. Now we got to eliminate another letter. Okay. So the next thing we want to do is we want to get a 1 in this spot. That's the next thing. So, using one of these 3 steps, how could we get a 1 where that red box is?
Swap 2 and 3.
No, I wouldn't give you a 1 there. If that was a 1, I would say yes.
Well, couldn't you do it and then multiply by -1?
You could, so you could turn this into two steps. You could swap them and then multiply by -1. You could. Or what else could you do?
Oh, you could add 2 and 3.
You could add 2 and 3. What else could you do?
Could you multiply row 2 by like a half?
Yeah, you could just multiply everything in row 2 by a half. Right? That's multiplying everything by a non-zero constant. So there might be different ways to get a 1 there, but the goal is you do need to get a 1 there. All right, since multiplying by a half, it's not going to give me that bad of a decimal. That's what I'm going to do. All right, so we're going to take row 2. We're going to multiply it by a half. And that's going to replace what's currently in what row?
2.
Yeah, we're going to replace what's in row 2. So the first part is like, what are you going to do? And then the second part after the arrow is where you're going to put it. So which 2 rows are not going to change?
1 and 3.
1 and 3. So we're going to just copy those down. So 1, -2, -3, 0. You can put a line there if you want to separate it. All right, and row 3 is not going to change. 0, -1, -1, 3. All right, and now what's my new row 2 going to be? 0, yep. 1. 0.5, that's not an awful decimal. If it was like, if I had to multiply by like 1/7, I probably would have tried to find a better way. But multiplying by a half is fine. And my last number?
-4.
-4. Okay, so now we got the 1, we got the 0, we got the 0, we got the 1. Okay. We're at the second to last step. Now we want to get a 0 where I have that little red number 5 indicating the step. Okay, so now let's do that. How could we get a 0 right there?
Add 2 and 3.
Yeah, we could just add rows 2 and 3 together. So let's take row 2, row 3, add them up. And that's going to be replacing what's currently in what row? 3. We're replacing row 3 now. So which 2 rows stay the same? 1 and 2. So what we're effectively doing now is we already eliminated the x. Now we're eliminating the y. So there's only going to be 1 letter left in row 3. And that letter is going to be what? Z. So when we're done this step, we're going to have a z, and we'll be able to solve for z. All right. So row 1 stays the same. Row 2 stays the same. There's a lot of things that stay the same in this, so there's a lot of copying over. And now add row 2 to row 3 and put that answer in row 3. What's 0 plus 0? 0. What's 1 plus -1?
0.
0. What's 0.5 plus -1?
-0.5.
-0.5. And if we need a calculator, we'll just get one. And then -4 plus 3.
-1.
-1. Okay. So now, let's take that last row and change it back to something with letters and see what we have. What does this say if you write this all out with letters, including the zeros? 0 x's plus 0 y's minus 0.5 z equals
-1.
-1. Well, we don't need that. We eliminated those. So all we really have is -1/2 z equals -1. And how would you get z by itself now?
Divide by -1/2.
Yep. Divide by -1/2. That's gone. And negative divided by a negative, that's gone. What's 1 divided by a half?
2.
2. Yep. And once you get your first answer, the rest of the problem is like what we did yesterday. Now you substitute it back in to get your other answers. So let's do y next. If we go back up, you could pick any equation I would say the easiest one would probably be to plug into probably this one, because there's already a 0 in the x spot. All right, so what did we just get for z?
2.
Okay, so plus 2y plus z equals -8. Okay, don't need that. So we get 2y, and take what you got for z. Z is 2. All right, and how would we move the 2 to the other side? Okay, subtract it. So that's going to give you 2y equals -10. And what would that mean y would equal? -5. Yep. So there's z, there's y, and then the last one you always do is x. So you pretty much, you'll always get the answers in that order. Z, y, x. All right, so now we're going to pick whichever one looks the easiest. You can't pick the top one because the top one doesn't have any x's. The second one, x minus 2y minus 3z. Okay. X minus 2y minus 3z. I think that was equal to 0. Okay, so x we don't know. What do we get for y?
-5.
-5. And what do we get for z? 2. Okay. What's -2 times -5?
10.
So -2 times -5 is +10. What's -3 times 2? -6. What's 10 take away 6? 4. And that would mean x equals?
-4.
-4. So the end result is still the same as what we did yesterday. It's just a different way of organizing your work. Okay. So let me just put that all on the same page so we can take a look at it. And those were our steps. Okay. Any question on the steps? We're gonna try another one. Okay. Most of the ones that I give you, they are going to come out to nice answers. So on the test, if you get something that's coming out to a decimal, probably means there's a mistake somewhere. All right, so let's try this one. Keep in mind, as you write it down, you might want to kind of do something as a pre-step before you even really start the problem. Anybody see something we might want to do here? And if we don't, well, actually, I guess we don't have to do that. But I'm just interested if anybody sees anything that they would want to do. Yep.
Divide the second row by 2.
Yeah, you could, because everything there is an even number, so why deal with bigger numbers? You could divide everything by 2 and use that as row 2. Just might make things a little bit easier. All right. But if you don't see that, you definitely don't have to do that. Okay. But let's do it. All right. So when we write this as a matrix, so I'm just going to kind of put down like a pre-step. Divide everything, or you know what, I'll say it this way. Instead of dividing by 2, that's the same as multiplying by what? Yeah, pre-step, I'm just going to say multiply row 2 by 1/2. Okay. What would be the top row in my matrix?
1, 0,
0, yep. 1,
4.
and then we just put that line there so we know that's the other side. You don't have to, but it just looks cleaner. So 1, 0, 1, 4. And now what would row 2 be if we take half of everything? 1, 1, 2, and 5. Yep. And now what would my third row be?
1, 6, 8, 4.
Okay, so remember the goal. You are focusing on that stuff. We want to get 1 in the top left and then zeros below it. That's the first step. So another way to say that is we are trying to get rid of the x in equations 2 and 3. We are eliminating x in equations 2 and 3. And there's no choice about that. That's what you have to do in this method. Okay, so we already have a 1 in the upper left, so that's good. How could we get a 0 in that spot? We can't just add row 1 and row 2 together. That would give me a 2. I'm going to have to do something to row 1 first. Then I can add it to row 2.
Multiply it by a negative.
Multiply it by negative what?
1.
1. Yep. So you're going to take row 1. You're going to multiply it by negative 1. And then you're going to add it to row 2. And that's going to replace what's currently in what row?
2.
Row 2. Now, this is the only time that I ever consider doing 2 things at the same time, because I want to get a 0 there and there. So we can do both at the same time. First, I check for the simplest thing. Can I just add row 1 and row 3 together and get a 0 in that spot? No. If I add row 1 and 3 together, what would I get in that spot there?
2.
I'd get a 2. That's not 1. So that means I do need to multiply row 1 by something first. What would I multiply row 1 by?
Negative 1.
Multiply it by negative 1 again. Then we're going to add it to the third row. And that's going to replace what's currently in what row?
Third.
Yep, third. Okay, so let's do those 2 things. Which row is not changing?
1.
Yeah, row 1, once you get the 1 in the upper left, row 1 can never change for the rest of the problem. If you change it, you're going to mess things up. So copy row 1 down. 1, 0, 1, 4. Okay, so now we're going to multiply by negative 1 and then add it to row 2. What's 1 times negative 1?
Negative 1.
Negative 1 plus 1.
0.
0. What's 0 times negative 1
0.
plus 1?
1.
1. What's, bless you, 1 times negative 1
Negative 1.
plus 2?
2.
Wait.
1.
1. What's 4 times negative 1? Negative 4 plus 5? 1. Yep. Okay. And we're doing the same idea again. Multiply the first row by negative 1 and then add it to row 3. Okay. What's 1 times negative 1?
Negative 1.
Negative 1 plus 1?
0.
0. What's 0 times negative 1? 0 plus 6? 6. Right? What's 1 times negative 1?
Negative.
Negative 1 plus 8? 7. And then times negative 1?
Negative 4.
Negative 4
0.
plus 4?
0.
0. The fact that we got a 0 over on the right side or we got some other ones in here, I don't care about that. All I care about is stuff that's in that triangle. That's all I care about. Okay, so we got a 1, we got a 0, we got a 0, and we already have a 1 in that spot. Okay, we didn't have that last time. Last time, we had to multiply that row by 1/2 to make a 1 in that spot. This time, it was automatic. Okay, so sometimes nice things like that happen. Okay, so now the next thing. You need a 0 right there. Can we just add row 2 to row 3 and make that a 0? No. And you can't use row 1 anymore. Okay? The reason you can't use row 1 is because if you took any multiple of row 1 and added it to these rows now, what would happen to those? They wouldn't be zeros anymore. So once you use the top row, after that first step, you can't use the top row ever again because you'll mess up your zeros. So you have to use the row immediately above it to fix the 6. All right. So now we need to multiply this second row by something.
-6.
Yep. So we're going to do -6 times the second row. And what row are we going to add to that? We're going to add that to row 3. And that's going to replace what's currently in row 3. So this time, it's just one step. Okay, that's the only time I ever do 2 steps at the same time. The very first step. If I need to. Okay, so when we do this step in red, what rows are not changing? Row 1?
Row 2.
And row 2. Whatever numbers are not right there are not changing. So row 1 and 2 are not. So 1, 0, 1, 4. This is an easy place to make a mistake if you copy a number wrong. 0, 1, 1, 1. And now let's do what we said. Multiply by -6 and add it to row 3. What's 0 times -6? 0 plus 0. 0. That's why we got those zeros there, so they won't mess up anything else we do in the problem going forward. Okay. What's 1 times -6? -6 plus 6. 0. 1 times -6 again?
-6.
Plus 7?
1.
1. 1 times -6?
-6.
Plus 0?
-6.
-6. Okay. So at this point, let's translate that bottom row back into an equation. We don't have to put 0x and 0y. We know those are 0. So essentially, what does this bottom row tell me?
Z equals -6.
Z equals, 1z equals -6. Now, sometimes this number is not a 1. In the last problem we did, it was a -0.5. So when we got to this step, we had to divide each side by that number. This time we don't. Okay. All right, so we got z equals -6. There's our first one. Okay. Now, go back up to the row right above it. What does that row tell me? 0 x's, yeah. 1y
1z
plus 1z equals 1. And now plug in what we just got for z. So y minus 6 equals 1. Okay, so what do we get for y? 7. Yep.
Can't you use the first equation that we started off with, like the very, like right when we first looked at the question, there's x plus z equals 4.
X plus z equals
Like
4. Yeah, you can use any of them.
Okay.
I usually just use the 3 that I have at the end right here,
Yeah.
and I start with the bottom one, then I go to the top one,
Yeah.
or the middle one, then I go to the top one. Yeah. So we got that one. And now what does that top equation tell me? 1x plus z. Yeah, it's the one we just said. And we're going to plug in z, -6. Okay. So now when we solve that, what do we get for x? We get 10. Okay, and that's the whole process. I admit a lot of nice things happened on that one. We got ones were exactly where we needed them, and zeros. Sometimes it takes a little longer, sometimes it's a little shorter. Okay, any question on that one? Okay. All right, do you want to try one, or you want to go through one more together? It's up to you. Which one? You want to try it on your own and then we go over it, or you want me to try to go through it with you?
I want to try my own.
Try it on your own. Okay. So try that one. I'll do it too. And see what you get. Okay, so first thing we want to do is copy these down. Is there anything that I should do as a step right when I'm copying them? Yep.
Swap 1 and 2.
Yeah, with what row?
Swap 1 plus row 2.
Yep, let's swap rows 1 and 2, just so we end up with a 1 in the upper left. So we have 1, 3, -1, -3. And then row 2 is going to be 2, -1, 0. And 0 on the other side as well. So 2, -1, 0, 0. And then row 3, we're just copying that down. 0, 3, 1, 8. All right. Any question on the first step? All right, now the second step is to get a 0 there. Already have a 0 in the lower left, so that row 3 is fine. We're not going to do two things in this step, just one thing. Can you add row 1 and row 2 and automatically get a 0 in the red box? Nope. Then we need to multiply row 1 by something first. Yep.
Multiply row 1 by -2.
Yep. So we're going to do -2 times the first row.
And add it to
Add it to the second row. And that's going to replace what's currently in
row 2.
row 2. So which two rows are unchanged at this step? 1 and 3. Let's copy those down. So 1, 3, -1, -3, and 0, 3, 1, 8. All right, so multiply by -2 and add it to what's below. What's 1 times -2?
-2.
Plus 2.
0.
0. What's 3 times -2?
-6.
-6 minus 1
-7.
gives me a -7. What's -1 times -2?
2.
2 plus 0 gives me a 2. And -3 times -2
6.
plus 0, 6. Okay, so your first column is done. Any question on that step? All right, now it's the next step. What number do you want to get in that box? You want a 1 there. Well, I could multiply everything by -1/7, but that's going to give me really messy fractions to work with. The other thing I can do is look at the row below it. Using the row below it, I can't get a 1 in the red box, but I could get a -1. If you add what's row 3 to row 2, would it make what's in that red box a -1?
No.
No. But is there anything we could multiply row 2 by and then add it, and it would make what's in that red box a -1? Yeah, we could multiply the bottom row by 2 and add it. Now, a -1 is not what we want, but it's so close to what we want that we can do it, and we can easily fix a negative after. All right, so let's take the third row. We're going to multiply it by 2, and we're going to add it to the second row. And that's going to replace what's currently where? In row 2. Yep. So rows 1 and 3 are not changing again. 1, 3, -1, -3. 0, 3, 1, 8. And now we're going to double everything in the bottom and add it to the middle. What's 0 times 2?
0.
Plus 0?
0.
0. What's 3 times 2?
6.
6 plus -7.
-1.
-1. What's 1 times 2?
2.
2 plus 2?
4.
4. Now 8 times 2?
16.
16 plus 6?
22.
22. Okay, so we avoided fractions for now. Doesn't mean you're going to be able to avoid fractions and decimals for the whole problem, but at least for now we did. Now, what number do we really want that to be?
1.
Yeah, we want that to be a 1. So what could we do to make that a 1?
Multiply those by negative one.
Yeah, just multiply that row by -1. So let's take the second row, multiply it by -1, and that's going to replace what row? That's going to replace the second row. So the second row is changing again. Rows 1 and 3 are not. 1, 3, -1, 0, 3, 1, 8, and that's going to become 0, 1, -4, -22. The reason we wanted to get a 1 here is because now it makes it easy to get a 0 there. All right, so now, can you add row 2 and 3 together to make what's in the red box a 0?
No.
Nope, then we have to multiply by row 2 by something first. Okay. What could we multiply row 2 by?
Negative 3.
Yep. So take row 2 times -3, and we're going to add that to row 3, and we're going to replace what's currently in row 3. Yep. Because we're only doing one step at a time, it does mean we have to do a lot more copying. If we start doing 2 or 3 steps at a time, it's going to be a lot less copying, but then it's going to be so many things to keep track of at the same time, it gets too confusing. All right, so copy rows 1 and 2. That's row 1. That's row 2. And now double everything. I'm sorry, multiply everything in row 2 by -3. What's 0 times -3? 0 plus 0. 0. Multiply by -3 and add it to the bottom. What's 1 times -3? Added to 3? 0. Yeah, multiply by -3 and add it to what's below. What's -4 times -3? 12. Added to what's below? 13. And what's -22 times -3? 66. Added to what's under it? What's 66 plus 8?
74.
74. So now at this step, we're done with the matrix. Now we're going to use substitution to get our answers. What does that last row tell me?
That z is like multiplied by 13.
So z multiplied by 13 equals 74. Yep. So now we're going to divide that out and see what we get. 74 divided by 13 is 5.69. So getting our answers will take a little bit longer because we do have to type them all in. All right. What does that second row tell me?
No x's.
No x's.
Y.
Yep.
Minus 4z.
Minus 4z.
Equals -22.
-22. And you're going to fill in what we just got for z. It's 4 times 5.69 equals -22. I need -4 times 5.69. That's -22.76. It's 22.76. And now, how would you move that -22.76 to the other side? Add it. Okay, so -22 plus 22.76 gives me, I guess I could have done that in my head, 0.76. There's y. And now let's go all the way up to the top row. What does the top row tell me?
X is 3y plus 3y.
It's 3y
Z
minus z equals -3. And let's fill it in. So x we don't know. 3 times 0.76. That's where I stopped over there, I think. Minus 5.69 equals -3. All right, so let's do 3 times 0.76. That gives me 2.28, and then subtract 5.69 minus 5.69. That gives me negative 3.41. So x negative 3.41 equals negative 3. And my last step?
Add 3.4 on both sides.
Yep. So negative 3 plus 3.41. Oh yeah, it's just 0.41. It's a little annoying when we have the decimals, but you can still do it. Okay. And those are our steps. Okay. Any question on those steps? And again, you can combine them, but I'm trying to show you just one step at a time to show the whole process. Let's finish up with 17. All right. So we'll take this one off the homework. So 17 is x minus 3y equals 6, and 2x plus y equals 19. All right. To write that as a matrix, what would be my first row?
1 minus 3 equals 6.
1 minus 3, 6. And my second row?
2, 1, 19.
2, 1, 19. So now, the only things that you're concerned about are those three numbers. When we do it in the other kind of problem, when we have 3 rows and 3 columns, you're concerned with all of these. That's 6 things you need to fix. Here it's half that. Okay, it's only 3 things. All right. So the first thing we want is a 1 in the upper left. Do we already have that?
Yeah.
Then we're already done one of the 3 things. So that's good. Now, what do you think we want to get there?
0.
We want a 0. Yep. If you add row 1 and 2 together, will it make it a 0?
No.
Nope. So then we got to multiply row 1 by something first.
Negative.
Negative 2. Yep. So let's do negative 2 times the first row. And we're going to add that to what row?
Row 2.
Row 2. And that's going to replace what's currently in
Row 2.
row 2. So which row stays the same?
1.
Row 1. 1, negative 3, 6. Okay, now let's do what we said. Multiply by negative 2 and then add to what's under it. What's 1 times negative 2?
Negative.
Negative 2 plus 2.
0.
0. What's negative 3 times negative 2? 6. Plus what's underneath it? 7. All right. 6 times negative 2 is
Negative 12.
negative 12. Added to what's underneath it?
7.
7. And we're done with the matrix. Now, the only thing I have to worry about is getting a 1 in that spot, but I'm going to translate it back to an equation to do that. What does that last row tell me?
7y equals 7.
7, oops, let's see, 7y equals 7, but you need a 1 in that spot. So what would you do on both sides?
Divided by 7.
Divide by 7. And we get y equals
1.
1. Okay, I told you it was a lot faster. That's your first answer. And now, plug that back into the top. Okay, what does that top row tell me?
X minus 3y equals 6.
6. And what did we just get for y?
1.
1. So x minus 3 times 1 equals 6. Negative 3 times 1 gives me
Negative 3.
negative 3. And what do we get for x?
9.
9. And that's, so you can see a 2-variable system with a matrix is a lot faster. So 3-variable gets longer. Then when you go to 4-variable, that's even longer. Okay, just adding one more variable makes the problem a lot longer. And if you get up to like 5 variable, that's kind of bordering on ones that are, it's going to take too long to even do by hand. There's a lot of places you could make mistakes. So at that point, we usually use a computer or something else to solve it. But 3 variable we can do by hand. It's not too bad. Now, one thing we didn't look at in this section is what happens if we get no solution or like an infinite amount of solutions. That's not something that we're going to take a look at with 3 variable problems. Okay, we did with 2. So I would definitely expect on the test you could see a no solution or all real numbers as solutions for 2 variable. But with 3 variable, it's always going to be like the ones we did in class. And they're going to come out on the test to nice numbers without decimals, at least for the 3 variable problem. Okay. All right. So that last question we did, that was 17. Okay, so the homework is 1 through 6, 18, 21, 24, and 31. There are only 2 problems in the homework that are 3 variable problems, because those ones take a while. I think it's 21 and 24. All right. So what I'll do now is, I still got about 6 minutes. I'll try to put the test topics up, and then I will be after school today if anybody needs to touch base with me.